Alright everybody, welcome to a brand new lesson, Chapter 5, Section 3, Sum and Difference Identities for Cosine. Alright, to get us started, I'm going to make a claim. And actually, it's a claim that you're probably familiar with. It might have shown up in previous examples or in your earlier studies. Cosine of A minus B is not equal to cosine of A minus cosine of B. This left-hand side expression here is not the same, is not equivalent to the right-hand side. To prove that for us here, let's consider letting A be pi over 2 and let B be 0. All right, cool. With this substitution, the left-hand side expression, cosine of A minus B, would be equivalent to cosine of pi over 2 minus 0, which of course is just cosine of pi over 2, which is equal to 0. So this whole left-hand side here, expression, cosine of A minus B, that quantity, is just equal to 0 when you let A be pi over 2 and B be 0. Now let's check out the right-hand side. What would that expression be? Well, cosine of A minus cosine of B with this substitution would be cosine of pi over 2 minus cosine of 0. Cosine of pi over 2 is 0 minus cosine of 0 is 1, so this is equal to negative 1. So we just showed that cosine of A minus B and cosine of A minus cosine of B are actually equivalent to two different expressions or two different values, so they're not equal. Okay, so then what is cosine of A, the quantity A minus B? And that's what I wish to show you in this first, in the first few minutes of this video. What is the identity? What is cosine of quantity A minus B really equal to? All right, to get us started, in order to derive a formula for cosine of quantity A minus B, let's locate two different angles, A and B, that are in standard position on the unit circle with the condition that B is less than A. Okay, guys, I've drawn us the unit circle here with angle A, you can see in red, goes from the positive x-axis. We know that because these angles are in standard position, and the terminal side is here, all right, in red. Angle B starts from the positive x-axis, and the terminal side is here in yellow. Tell you what, let's say that the point at which angle A, the terminal side of angle A, hits the unit circle, let's call that point S, okay? And the point at which the terminal side of angle B hits the unit circle, let's call that Q, right there, that point there, okay? Also, let us call this point here, since this is a unit circle, let's call this point P. We would know on the unit circle that the coordinates for point P are 1, 0. And let's call the point at the origin here O. All right? The next thing I want us to do is I want us to find point R on the unit circle such that the angle POR equals the difference between angles A and B. Let's see if I can draw this for you. So locate point R on the unit circle. It'll probably be somewhere like over here. Point R. Point R on the unit circle is there because now this angle, supposedly, POR, is actually equal to, this angle here, POR, is equal to the difference of A minus B, all right? A minus B. So this angle here, see if I can show it to you here, from there to there, that angle measure is A minus B. Here, where should I write that? A minus, hopefully you can see this, A minus B, okay? The measure of this angle here is A minus B, okay? Cool. Now, because point Q is on the unit circle, we know that the coordinates, right, the x-coordinate is actually cosine of B, right? Cosine of angle B. Cosine of this angle, B here, is the x-coordinate for that, point, and the y-coordinate is sine of angle B, right? Because, again, this is the unit circle. Similarly, for point S, the coordinates for point S are going to be cosine of A, comma, sine of A. Those are the coordinates for, this is sine of A right there, for point S here. We know that because point S lies on the unit circle. And now point R, remember what this angle is here. POR is the angle A minus B. That tells us that R, the point R on the unit circle, has coordinates cosine of angle A minus B. That's your x-coordinate, comma, sine of A minus B. Okay? Those are the coordinates for point R. Okay, guys, the next thing I want you to notice is, notice that angle SOQ, what is the measure of angle SOQ? You may want to pause the video right here and see if you can figure out what the measure of angle SOQ is. SOQ. All right, you should determine that the measure of angle SOQ is A minus B. All right, so I have angle SOQ equals A minus B. That means, notice that the central angles SOQ and POR are equal. This angle SOQ and POR have the same measure. SOQ and POR have the same measure. What we can say now, therefore, is the following. These two chords, chord SQ, that chord there, and this chord here, PR, those two chords have the same length. That is to say, they're equal. This chord, by plane geometry, this chord SQ is equal to chord PR. So what I'm going to do now is I'm going to use the distance formula to state that these two distances from S to Q and from P to R are the same. I'm going to have to scroll the screen up, okay? So bear with me. All right, so we know that chords PR and SQ are equal. So by the distance formula, we can say that the square root of cosine of A minus B, okay, minus 1 quantity squared, okay, plus sine of A minus B minus 0 quantity squared. The square root of all of that, okay? You may want to review the distance formula before you actually look at this proof, but all of this here that we just wrote is the distance of PR. And the distance formula says that that is going to be equal to, okay, is equal to the distance of SQ, which happens to be the square root of cosine of A, cosine of A minus cosine of B, quantity squared, plus sine of A minus sine of B, quantity squared. Okay, the square root of all that. Okay, this is really the left-hand side here. All of that is equal to the right-hand side by the distance formula. And all of this is just the distance of SQ. Okay, cool. What we can do right now is square both sides. If we square both sides, the square roots are gone, okay? Remember, these are just distances. Now, if we square both sides, then I have cosine of, then I'll have cosine of A minus B squared, minus 1, quantity squared, plus sine of A minus B minus 0, quantity squared. That's the left-hand side. All of that is equal to cosine of A minus cosine of B, quantity squared, plus sine of A minus sine of B, quantity squared. Okay, all I did right now was square both sides, so now the statement doesn't have any square roots. Now what we can do is we can expand these perfect squares here, right? So we can expand this, and we can also expand this, we can expand this, and we can expand this, all right? So let's work on that. So the left-hand side, we're going to get, let's see, cosine squared of A minus B minus 2 times cosine of A minus B plus 1. What I did right now is just expand this right here. Again, you know that this means cosine of quantity A minus B minus 1 times cosine of quantity A minus B minus 1, and then you FOIL, and then you'll get all of this, all right? Now, this is minus 0, so you just disregard that. So you're just going to get plus sine squared of A minus B. So plus sine squared of A minus B. All right, all of this is the left-hand side of that expression, okay? Which is now equal to, now I'm going to expand this binomial and expand that binomial there. All right, the right-hand side will be cosine squared of A minus 2 times cosine of A, cosine of B, plus cosine squared of B. Okay, so all of this here, all of this is the expansion of that binomial. So all I have left to do now is to expand this binomial. So let me do that for us now. Plus sine squared of A, see if I can fit this in here, minus 2 times sine of A, sine of B, and it looks like I just need a little more room. Let me move up a little bit. Plus sine squared of B. All right, so now I have both the left-hand side and the right-hand side. So let's see what we have here. So I want you to notice that on the left-hand side, you have, here, let me see if I can highlight it for you, cosine squared of A minus B and sine squared of A minus B. Cosine squared of A minus B plus sine squared of A minus B. That's the Pythagorean identity, which is equal to 1. So I'm going to replace both of those with 1. On the right-hand side, notice that you have cosine squared of B plus sine squared of B. That equals 1. Okay? Oh, look at this. You got cosine squared of A plus sine squared of A. That's equal to 1 as well. So we can replace those expressions with the numbers 1. All right? So let me move all this up here. I think we're good. I think that's what we want to be here. Right there. All right, so I have on the left-hand side here, I have on the left-hand side 1 minus 2 times cosine of A minus B plus 1 is equal to let me highlight what I just did. This plus this is 1. That's what this 1 is. Then I brought down this term right here, and then this 1 right there is that 1. Okay? Now on the right, I am going to have 1 minus 2 times cosine of A minus, or cosine of A, cosine of B, plus 1 minus 2 times sine of A, sine of B. Let me highlight what I did on the right. So this cosine squared of A plus sine squared of A is 1, which is right here. This term, I brought it down right there. And then cosine squared of B plus sine squared of B is plus 1 by the Pythagorean identity. And then minus 2 sine A sine B is right here. All right? Now let's combine like terms. So on the left-hand side, you can see you have a 1 plus another 1. We know that to be 2. I hope you're following me here. On the right-hand side, notice that you have a 1 plus a 1, which is 2. All right. See if I can fit everything here. I might be able to, barely. All right, so the next thing I want you to do is to divide both sides by 2. Notice that every single term is divisible by 2. So let's divide everybody by 2. Okay? Actually, before we do, excuse me, let's do this. Let's cross-cancel those 2 terms, right? You got a 2 on both sides. Now let's divide everybody by 2. All right? When you divide everybody by 2, you have negative cosine of A minus B. Dividing every term by 2 on both sides. Minus cosine of A, cosine of B, minus sine of A, sine of B. Now remember, we divided everybody by 2. Now let's divide everybody by negative 1. Then you're going to get cosine of A minus B. Now here it is, folks. Cosine of A minus B is equal to cosine of A times cosine of B. And plus, oops, sorry about that. Plus, okay, let's just get the right color here. Plus sine of A, sine of B. All right, very good. Now this, you guys, is the difference identity for cosine. All right, we did it. Okay, thanks for bearing with me. Now watch this. A few things I want you to notice. The difference identity for cosine keeps your cosines together and your sines together. Cosines are together, your sines are together. Second thing that I want you to notice is this is a difference and the expansion has a plus. So the difference identity for cosine changes your sign. This is minus, this is plus. Okay? All right. Using this pattern, I wonder if you and I can get the sum identity for cosine. All right? So let's see. Maybe you can pause the video right here and see if you can use the pattern that I just highlighted to get the expansion for the sum identity for cosine. All right, so cosines are going to be together. So cosine of A, cosine of B. It's going to be the opposite sign, so minus, and then sines together. So sine of A, sine of B. Good job. All right, so this is the sum identity for cosine. These two identities you're going to want to know really, really, really well. All right, we derive them from scratch. The rest of this section just has us applying these two identities. Okay, you guys, now that we have our two identities, I was nice enough to remind you what the identities are up here so we can always see them. Here's example number 1, okay? Find the exact value of each expression. So the first thing we're going to try to find is cosine, the value of cosine of negative 75 degrees. Okay, now, if we're going to use one of our identities, for this expression, that means we have to try to rewrite this argument as either a sum or a difference, either a sum or a difference. Okay, so let's see. I think I can write it as a difference. So if I say that cosine of negative 75 degrees is the same thing as, or is equivalent to, cosine of, let's see, I can do, what can I do here? What we can do is do negative 45 degrees, right? Plus, let's say, negative 30 degrees. I guess that's not a difference, that's a sum. All right, negative 45 degrees plus negative 30 degrees is negative 75 degrees, so this definitely works for us. So you can see that we were successful in rewriting our original expression as a sum. So now what you're going to see me do is follow the pattern for expanding a sum for cosine. It'll be cosine of A, cosine B, minus sine A, sine B. Now keep in mind, negative 45 degrees, here I'm going to label it for us. Negative 45 degrees is like your A in your identity. And negative 30 degrees is like your B in your identity. All right? All right, let's go for it, guys. All right, I think I'm going to need more space here, so let me actually get rid of this. All right, let's use the identity here. So this is equal to cosine of negative 45 degrees. That's really sloppy. Let me rewrite that for you. Cosine of negative 45 degrees, okay, times cosine of negative 30 degrees. All right, this is the pattern. Minus the sign change, right? Minus sine of negative 45 degrees times a sine of negative 30 degrees. All right, cool. If you can't read that, this is sine of negative 45 degrees. All right, let's keep evaluating. So cosine of negative 45 degrees is root 2 over 2. Positive. Cosine of negative 30 degrees is positive root 3 over 2. Again, positive, because you're in quadrant 4 when you are at negative 30 degrees. Minus sine of negative 45 degrees is negative root 2 over 2. And sine of negative 30 degrees is negative 1/2. All right, cool. So then this is root 6 over 4 minus root 2 over 4. All right, which gives us the final expression value, which is root 6 minus root 2 all over 4. That's the final value of that expression, cosine of negative 75 degrees. Notice that you could have gotten this final answer by rewriting the argument negative 75 degrees different than I did, but the good news is that we all end up with the same answer. All right, cool. Let's look at another one. All right, they want you to find cosine of 17 pi over 12. All right, now we can find this the value of this expression if we rewrite it as a sum or a difference, right? So what we can do is here, actually, before I go much further, let me see if I can remind you what your identities say. There they are. All right. So let's see. I can rewrite this as cosine of, I think, a sum here. How about, yeah, that would work. How about 9 pi over 12 plus 8 pi over 12? That would definitely, undoubtedly be 17 pi over 12. But when I simplify each of these, this would be 3 pi over 4, which is one of our special angles, plus simplify this one, 2 pi over 3. Another one of our special angles. All right, cool. So let's use a sum or the sum identity for cosine to expand this. All right. So then this is going to be cosine of 3 pi over 4 times cosine of 2 pi over 3. Remember the sign change, minus sine of 3 pi over 4 times sine of 2 pi over 3. Cool. So then cosine of 3 pi over 4, that's in quadrant 2, so that's negative, and it is negative root 2 over 2. Cosine of 2 pi over 3 is, 2 pi over 3 is in quadrant 2 as well, and that will be negative 1/2 minus sine of 3 pi over 4, that will be positive root 2 over 2. Sine of 2 pi over 3 will be positive root 3 over 2. All right, cool. So then this is positive root 2 over 4 minus root 6 over 4, which can be rewritten as root 2 minus root 6 all over 4. And that's the value of that expression. Awesome. All right, let's do one more like this. They want you to find the value of the following expression. They've given you cosine of 173 degrees times cosine of 83 degrees plus sine of 173 degrees times sine of 83 degrees. Now, if you look at this expression, this follows this expansion here. That must mean this expression here, which matches this, must be able to be rewritten as the left-hand side. All right, everybody? So this is the pattern here that I'm pointing at of what we have. I'm going to rewrite it like this, all right? Okay, so here we go. So this is actually going in the opposite direction. So then this is the same thing as cosine of, here, I'm going to do this for us. This is like your A, and 83 degrees is your B. 173 degrees is A, and 83 degrees is B, right? So then when I use my identity, it'll be cosine of A minus B, which is 173 degrees, minus 83 degrees. Okay? So then this is cosine of, let's see, then this is going to be 173 degrees minus 83 degrees, which is 90 degrees. And cosine of 90 degrees is 0. So the final answer is just 0. Cool. Okay, guys, example number 2, find one value of theta that satisfies each of the following. All right, here's the first example they want you to consider. Secant of theta, secant of some value theta is actually equivalent to cosecant of 62 degrees. All right, cool. What I want you to remember is that secant and cosecant are cofunctions. Secant and cosecant are cofunctions. And so what we know from earlier studies is that cofunction values of complementary angles are equal. I'll say that again. Cofunction values of complementary angles are equal. That is to say, secant of theta is equivalent to cosecant of 62 degrees if and only if theta and 62 degrees are complementary. So what I can do is I can take theta and say theta plus 62 degrees must be equivalent to 90 degrees. That's the only way this statement holds any water. When I subtract 62 degrees from both sides, I get my answer of 28 degrees. All right, cool. That's the value of theta that makes this statement true. All right? Good job, you guys. Let's look at another example. What they have for you now is tangent of theta is equivalent to cotangent of negative 54 degrees. Now, again, what I want you to realize is that tangent and cotangent are cofunctions. So the only way that this can be equivalent, the left-hand side can be equivalent to the right, is if theta and negative 54 degrees are complementary. That is to say, theta plus negative 54 degrees must sum to 90 degrees. All right, when I add 54 degrees to the right-hand side, 90 degrees plus 54 is 144 degrees. That's what theta must be. Okay? Because cofunction values of complementary angles are equivalent. All right, cool. Let's do one more. Like this. So they have for you cosine of theta is equivalent to sine of 7 pi over 6. Now, again, all of these examples are pretty similar. Cofunction values of complementary angles are equal. So cosine and sine are cofunctions. So then the only way this is true is if theta and 7 pi over 6 are complementary. That is to say, theta plus 7 pi over 6 is equal to pi over 2. You know pi over 2 is the same thing as 90 degrees. So then theta must be equal to pi over 2 minus 7 pi over 6. Right? Well, that's the same thing as 3 pi over 6 minus 7 pi over 6. Right? So then theta is negative 4 pi over 6. And that is to say theta is equal to negative 2 pi over 3. That's what theta must be. All right, cool, guys. Again, this is emphasizing what we've already studied, and that is cofunction values of complementary angles are equal. Example 3, write the following expression as a trig function of theta alone. As a trig function of theta alone. All right, so they've given you cosine of 90 degrees plus theta. Of 90 degrees plus theta. Now, what they want is they want an expression or a trig function of theta alone. In other words, they want this argument to not be a sum, but just theta alone. All right, cool. So what we can do is we can use our sum identity for cosine to expand this. So then this would be the same thing as cosine of 90 degrees times cosine of theta minus sine of 90 degrees times sine of theta. Now, we all know cosine of 90 degrees is 0. So that's 0 times cosine of theta minus sine of 90 degrees is 1 times sine of theta. So then this whole thing is just 0 minus sine of theta, which is the same thing as negative sine of theta. That's all they wanted you to do, folks, is rewrite the original expression as a function of theta alone. That's it. Good. Okay, guys, example 4. Find cosine of s minus t, given that both s and t are in quadrant 4, and that, this is also given, okay? Cosine of s is equal to 15/17. And this is also given, sine of t is equal to negative 24/25. All right, here is all the given information in white. S and t are both in quadrant 4, and cosine of s is 15/17. Sine of t is negative 24/25. All right, this is what they're asking you to find. Cosine of s minus t. Now, by the difference identity for cosine, this is the same thing as saying find cosine of s, cosine t, plus, you know, that's why I don't like t's, because sometimes they can look like plus signs. Let me do a capital T for cosine, for t, all right? Plus sine of s, sine of t. All right, very good. This is the difference identity. All of this here is from the difference identity for cosine. Okay, very good. Now, look at this, guys. Cosine of s is given to us. Cosine of s is 15/17. What we don't know is cosine of t. We got to find that. Sine of s, we don't know that either, but we do know what sine of t is. It is negative 24/25. So do you see what it is we're missing here? In order to figure out the value of cosine of s minus t, we just need cosine of t and we need sine of s. So how do I take what's given to me, that is sine of t is equal to negative 24/25, and use this fact? How do I use sine of t in order to find cosine of t? All right, that's the quest. That's the challenge. All right, here we go. This is what we know for sure. We know that cosine squared of t plus sine squared of t is equal to 1. That's the same thing as saying cosine of t is equal to plus or minus the square root of 1 minus sine squared of t, right? If you isolate cosine of t. Now, do you remember where t is? It's in quadrant 4. And in quadrant 4, cosine is positive. So then I can ditch the negative root and just say it's equal to this. Now, positive square root. 1 minus. Now, sine of t is given. It is negative 24/25. And according to the Pythagorean identity, this must be squared right there. All right? So, cosine of t, right? Let's see. From here, go up here, all right? So then cosine of t is equal to the square root of, let's see, this is going to be, do a little arithmetic here. And we're going to get, let's see, 625 over 625. That's the number 1, okay? Minus 576 over 625. That is 24 over 25 squared. All right, so cosine of t is equal to, let's see, this is the square root of 49 over 625. Oops, I'm sorry. Sorry again. So then cosine of t is 7 over 25. Cool? So let's plug that value in. I'm going to plug that value in now. Cosine of t is 7/25. Okay? Now what I want to do is find, the only thing I'm missing now is sine of s. Sine of s. So I want to take what's given to me, cosine of s, and find sine of s using the same Pythagorean theorem. All right, let me move the screen up a little bit. Okay? All right. So I need sine of s. So this is what we want to remember. Cosine squared of s plus sine squared of s is equal to 1. And I need sine of s, so I'm going to solve for sine of s. It's equal to plus or minus the square root of 1 minus cosine squared of s. Now, remember, s is in quadrant 4, and sine is negative there, so we're going to take the negative square root. Now, cosine of s is given to me. Cosine of s, I'm going to scroll up if you guys don't mind. Cosine of s, oops, sorry about that. Cosine of s is given. Cosine of s is 15/17. So I'm going to plug that in, okay? Okay, so here it is. I'm going to have 1 minus 15/17 squared. Like that. Okay, cool. Some arithmetic will give you, let's see, 289 over 289. That's the number 1 minus 225 over 289, which is equal to the negative square root of, let's see, this is going to be 64 over 289, which is negative 8 over 17. So I can take this value and plug it into the expression that I had earlier. If you allow me to scroll up for a second, I'm going to plug this number in. All right? So right here, I can come here now and plug it in. You know what? I already forgot what we got. Let me scroll back down. Negative 8/17. Negative 8/17. Negative 8/17. All right, cool. Let's do it. Negative 8/17. All right, guys. So the final answer will come from evaluating all of this. All right? Cool. All right, so then right here, we get 15 times 7, which is 105 over 17 times 25, which is, what is that, 425? Alrighty, so 105 over 425, plus, this is going to be plus, 8 times 24, which I believe is 192 over 425. So the final answer here is going to be 297 over 425. This is the value of the expression. Cool. Good job. That was a pretty cool example. Okay, guys, this wraps up the section 5.3 for us, sum and difference identities for cosine. The next video will be the sum and difference identities for sine and tangent, 5.4. So I'll see you later in that video.